Welcome to this tutorial on the spring-based smoothing method in ANSYS Fluent. This video is part of my complete dynamic mesh tutorial series designed to help you master moving and deforming mesh techniques in CFD. In this video, you will learn what spring-based smoothing is, how it works inside ANSYS Fluent, where it is useful, and its major limitations. I will also walk you through a simple demonstration so you can clearly understand its behavior in real simulations. Spring-based smoothing is one of the core methods used by Fluent to update mesh positions during dynamic mesh simulations. In this method, mesh nodes behave like they are connected to each other with tiny springs. As the boundary moves, the internal mesh stretches smoothly, preserving continuity. Imagine your mesh as a network of springs. When the boundary moves, the spring forces distribute the displacement into nearby cells, allowing the mesh to deform smoothly. This method is ideal for small and continuous motions, because it does not add or remove cells, it simply stretches the existing mesh. Next, we look at the key mesh smoothing parameters. The spring constant factor controls how stiff the mesh behaves during deformation. Convergence tolerance sets how precise the smoothing needs to be. Maximum number of iterations defines how long Fluent will continue smoothing. And Laplace node relaxation adjusts how smoothly the nodes reposition during the update. This is the geometry and mesh used for the simulation. The domain is fixed, and the circular object is defined as a dynamic zone. For meshing, a triangular mesh method is used. A uniform mesh size of 25 mm is applied across the domain. Triangular elements are chosen because they adapt well to curved boundaries and provide smooth deformation when using dynamic mesh techniques. Named selections are created for the inner edge around the moving object, and for the outer edge of the domain. These named selections will be used inside Fluent to define motion zones and apply dynamic mesh settings. Here, the dynamic mesh option is enabled to activate mesh motion for our setup. Next, we move into the smoothing settings, where the spring-based method is selected to manage mesh deformation. These advanced parameters are shown here, and for this demonstration, we keep the default values. Now we proceed to the user-defined function workflow. The previous code is cleared, and the new motion UDF is loaded into Fluent. After loading, the code is compiled and successfully built, making it ready to control the boundary movement. Next, we create the dynamic zone for the model. The inner edge is assigned the motion UDF, and rigid body coupling is enabled so that the surrounding mesh follows the boundary movement accurately. With that done, the solution is initialized to apply our updated settings. We then switch the solver to transient mode, which ideally should be selected at the beginning of the setup. Finally, we preview the mesh motion. In the dynamic mesh panel, image saving is enabled, and the PPM format is selected. PPM files provide high-quality frames, making them ideal for generating smooth animations later. We set the time step size to 0.15 seconds and define 200 total time steps. After that, we click Preview to generate and save the mesh motion frames automatically. Here you can see the spring-based dynamic mesh in action. It's ideal for smooth boundary motions and small deformations, giving stable mesh updates. However, it becomes less effective for very large or highly distorted movements, where remeshing or layering methods may be required. If you want personalized one-on-one ANSYS Fluent or CFD training tailored to your project or industry requirements, feel free to contact me. I provide complete guidance for beginners, working professionals, and research students. My WhatsApp number and email are available in the description box. And if you found this video helpful, please don't forget to like, subscribe, and share.